It's almost breathtaking how quickly AI is evolving, isn't it?
It really is.
We're moving way beyond, simple data crunching. Now we have systems that seem to grasp and interact with the world in these incredibly nuanced ways. It really makes you stop and think. How are these advanced systems actually thinking? How are they making sense of everything?
That's the core question, absolutely. And it's precisely what we're diving into today. We've gathered, a fascinating collection of sources.
Okay.
We've got the latest AI research papers, some really detailed industry reports, insightful news articles, even some chatter from, the developer community.
Like a good mix there.
Yeah, and what's really exciting is that they all seem to point towards some fundamental shifts in AI architecture, particularly in how we're trying to build AI that thinks, a bit more like us.
More human-like.
Sort of.
Yeah.
An AI that can engage with the world in all its rich complexity, what we call multimodal.
Multimodal, right? That's a key concept here. We're not just talking about AI that deals with text anymore, are we?
Not at all. It's about systems that can truly understand and process information across images, audio, even video, and then generate responses in all those different forms too.
Okay, so the mission for this deep dive, for you listening right now, is to really unpack these cutting-edge advancements in AI architecture. We'll be exploring these ideas behind fast and slow thinking in AI and the amazing potential of these new multimodal models.
Exactly.
Think of this as your shortcut to understanding where AI is headed next. Okay, let's really get into this.
Yeah, Liz, a fantastic place to begin is with this idea of modeling thinking that's, more akin to how humans operate.
Okay.
One of the research papers we looked at introduces a fascinating concept. It's called the talker-reasoner architecture.
Talker-reasoner, interesting name.
Isn't it? And what's intriguing here is the clear separation between two distinct processes. You've got a talker, which is responsible for that quick, almost instinctive language generation.
Yeah.
And then there's a reasoner that engages in, slower, more deliberate analysis, deeper thought.
Right. So it's like having two specialized AI components working together, almost like different parts of the brain.
Kind of, yeah. As I understand it from the paper, the talker can rapidly produce an initial response, like a first draft.
Okay.
And then the reasoner steps in to critically evaluate that response, maybe refine it, add layers of more profound insight.
And the results. Did it work?
They were pretty compelling, actually. The paper showed this dual approach outperformed traditional AI models on various language tasks. It really seems like that reasoner adds a crucial level of, let's say, sophistication.
Right, that deliberate checking step.
Precisely. And the critical analysis section of the paper, it offers a valuable perspective here. It highlights the significant potential of this architecture, to strike that balance between speed and depth.
Speed and deliberation, something we humans do all the time.
Exactly, instinctively. But it also gives a realistic outlook. It notes there are still practical hurdles, challenges to overcome in bringing these kinds of systems into, widespread use.
Yeah, I can imagine. Still, that's one of those aha moments, isn't it?
It really is.
You immediately see the logic. Trying to engineer AI that mirrors how our own minds handle things, those quick reactions followed by more thoughtful processing, it gives you a real peek under the hood at the design principles researchers are exploring.
Yeah, absolutely. And building on this notion of more sophisticated processing, we're seeing just remarkable progress in multimodal AI models.
Okay, so moving beyond just text and reasoning.
Exactly. The Google DeepMind report on their Gemini family of models, that's a perfect illustration.
Gemini, right. Heard a lot about that.
And what's so significant here is that Gemini isn't just one model. It's a whole suite, Ultra, Pro, Nano. And they're all designed from the ground up to understand and process information across, a huge range of formats. Text, images, audio, video.
That feels like a real turning point. Not just an AI describing a picture, but one that can understand the content, connect it with text, use that combined understanding to, reason.
Precisely. And answer complex questions based on it. The report really emphasizes the groundbreaking performance of Gemini Ultra in particular.
How good are we talking?
Well, get this. Gemini Ultra actually surpassed the performance of human experts on the MMLU benchmark.
Seriously? Human experts?
Yes. And MMLU tests knowledge across, I think it's 57 diverse subjects.
Yeah.
It's massive.
Wow.
It also achieved new state-of-the-art results in numerous other multimodal benchmarks.
Sure.
Consider this example from the report. It can decipher handwritten notes within a complex physics problem.
Okay.
And then generate the solution in LaTeX format.
That's very specific. And impressive.
Or achieving exceptionally high accuracy on subjects demanding expert-level knowledge. I mean, this isn't just a minor tweak. It suggests AI is now capable of exceeding top human expertise in broad knowledge domains.
Which has huge implications.
Right.
For, well, everything. Work, education.
Profound implications, yeah.
Yeah.
It really paints a vivid picture of the level of comprehension we're now seeing.
And it's not just the understanding, right? It's the scale behind it. The report mentions the massive training effort.
Oh, absolutely. Using their specialized chips, the TPU v5e and TPU v4, training Gemini Ultra across multiple data centers. It sounds like a truly Herculean effort.
Must be.
It is. And the examples of Gemini's multimodal reasoning are really impressive, too. It can, say, analyze charts and provide detailed answers based purely on the visual data.
So interpreting graphs.
Yes. Or identifying various plant species just from images. Even creating imaginative content, like writing a blog post and automatically generating relevant visuals to go with it.
So it's moving beyond just recognizing elements.
Right, to actually grasping the intricate relationships between them. It's not just seeing a picture and describing it, but truly understanding it, connecting it to existing knowledge, making inferences, kind of like we do.
Right. Right. Which actually brings us to another interesting model we saw mentioned, the Qwen 2.5 Omni.
Ah, yes. That one popped up in some Reddit discussions and an article on LearnOpenCV.
And it seems to be pushing similar boundaries, handling multiple data types seamlessly.
It does. You can take in text, images, audio, and video, and then output both text and, interestingly, speech.
Text and speech out. Okay.
What's particularly noteworthy about Qwen 2.5 Omni is its architecture. They call it Thinker-Talker.
Thinker-Talker. So similar idea to Talker-Reasoner.
You can definitely see a conceptual parallel, yeah. The Thinker part is basically the large language model component, the bit that handles text generation and understanding.
Okay.
While the Talker is specifically designed to generate audio directly from the thinker's internal understanding, they talk about using hidden representations.
Which is like the AI's internal thought process.
Exactly. The complex understanding it develops. The Talker uses that rich internal state directly to create audio. The whole thing is engineered for, well, seamless end-to-end training and use across these different modalities.
And they've tackled real-time audio generation, too. Something about a sliding window DIT.
That's right. It's all geared towards making that fluid, real-time interaction possible. And the excitement around its performance on multimodal benchmarks seems pretty significant.
How so?
It's being recognized for achieving a new level of sophistication in following instructions given in speech, apparently almost matching its already impressive text-based capabilities.
That's a big deal for voice assistants and the like.
Absolutely.
Yeah.
And if we connect this back, to your interest in quickly gaining knowledge, seeing multiple perspectives, the ability of these models, both Gemini and Qwen 2.5 Omni, to process and understand such diverse data and reason across them, it offers a powerful new way to interact with information.
Okay, so these incredible capabilities, they obviously stem from a mix of factors, which leads us to the data they're trained on and their actual design, their architecture.
Exactly. Those are crucial pieces.
And that research paper comparing ChatGPT 4.0 and Gemini 1.5 on pediatric nephrology questions, that seemed to really highlight this point.
It really did. What's particularly revealing there is how differently these two advanced models behaved.
How so?
Well, ChatGPT 4.0 showed a strong baseline knowledge in this specialized medical field, right out of the box.
Okay, pretty good to start with.
Yeah. But surprisingly, it didn't show a significant improvement after being specifically trained using these educational review articles.
Huh. That is surprising.
Right. On the other hand, Gemini 1.5, which started out maybe a bit less accurate, showed a substantial increase in performance after being trained on the exact same material.
A big jump for Gemini, then.
A very big jump. And this improvement was particularly noticeable when the training data was given as simple TXT files.
Plain text files work better than, say, PDFs?
Apparently so, for Gemini 1.5 in this study. The paper suggests, or hypothesizes, that the cleaner, less cluttered data format of TXT made it easier for the model to locate and process the relevant information compared to the, more complex formatting you often find in PDFs.
Interesting. So the format of the training data really matters.
It seems to, potentially quite a lot depending on the model. And this brings us right back to the importance of architecture. Well, the findings suggest that the internal design of models like Gemini 1.5 Perhaps its underlying mechanisms for storing and retrieving information, when combined with these simpler data formats, can have a profound impact on how effectively they learn. It really makes you consider how those Cocker-Reasoner and thinker-talker approaches we talked about might also play a role in how these models utilize new information.
So the way they're built internally affects how well they learn from different kinds of input.
It certainly seems that way. The underlying architecture, perhaps even how those talker and reasoner parts are structured, could significantly influence learning effectiveness.
It's like the architecture is the framework.
Yeah, the data fills it in. Yeah.
Okay. And speaking of architecture, we also came across this concept of diffusion transformer, or DDIT models, from an NCORD guide. That seems like another big shift.
It is, yeah. What's fascinating about DDITs is they represent a departure from the traditional approach in diffusion models, the ones used for generating images. They essentially replace the UNet convolutional neural network, which was like a standard component with a transformer architecture.
The same kind of architecture used in large language models.
Exactly.
Yep.
And the fact that DITs are getting excellent results demonstrates that the specific built-in advantages of CNNs, their sort of natural affinity for image patterns, aren't actually essential for the impressive performance of these diffusion models. That was a key insight.
And these DITs, they scale well.
Apparently, yes. Very well. As you increase the model size and the training data, you generally see better and better performance. The guide highlights their use in text-to-image and even text-to-video models.
Like OpenAI's Sora and Stable Diffusion 3.
Precisely. It really looks like transformers are becoming the fundamental building blocks for many of these cutting-edge generative AI systems. This shift towards transformer architectures like DIT, it's crucial for the kind of amazing text-to-image and text-to-video stuff we're seeing, because transformers are just so good at understanding long-range connections in data.
Got it.
And, there are ongoing innovations even within transformer architectures, all aimed at achieving even greater scale, handling incredibly long sequences of data.
Like what?
Well, the AI Resources article we saw discusses something called ring attention with blockwise transformers.
Ring attention? Sounds circular?
It kind of is. Imagine trying to pass a really long message around a group of people, but each person only has limited memory.
Okay.
Ring attention is like breaking the message into smaller chunks. Each person focuses on their part, but they use a circular system to pass information along, ensuring everyone eventually gets the full context without anyone's memory overflowing.
Ah, I see. It's a way to manage context without needing infinite memory.
Exactly. This approach breaks down the input into manageable blocks, processes them iteratively, and uses this ring-like memory mechanism to handle context. They claim it can handle near infinite context lengths.
Which would be huge for processing long documents or videos or code.
Absolutely. So we're seeing all these different innovative approaches to tackle the fundamental challenges of building these massive, highly capable AI systems.
Yeah, whether it's about mimicking human thinking processes or finding new architectural structures for better learning and scale.
Right.
Now, all this amazing tech progress, it's starting to have a real impact out there, right? In the real world.
Absolutely. It's not just research anymore. The Gemini at Work 2024 article provides some really compelling examples of businesses already leveraging Gemini.
Like what kind of things?
Well, companies using it to analyze huge amounts of operational data, find insights they couldn't see before, generating more personalized, more effective communications with customers, significantly enhancing customer service interactions.
And they mentioned specific companies.
They did. Click Therapeutics, using it to streamline patient experiences in clinical trials. Dun & Bradstreet, building tools to help their sales teams create more targeted messages. Even in animal health, Elanco is integrating it across key operational processes and apparently has already seen a significant return on investment.
Wow, already seeing ROI. That really underscores the practical benefits these advanced models are bringing, and across really different industries, too.
It does. And if we step back, look at the bigger picture. That Multimodal AI Research Report 2025 forecasts just substantial market growth.
How substantial?
They're projecting a jump from, USD 1.6 billion in 2024 to USD 27 billion by 2034.
27 billion in 10 years.
That's the projection. It's almost hard to fathom that kind of growth.
What's driving it?
The report points to key drivers like, well, increasing demand for automation everywhere, rising customer expectations for more personalized, seamless experiences, and the growing adoption of AI-powered tools for creating content.
It really highlights how fast this field is moving and how, well, pervasive AI could become.
Definitely.
Okay, so to try and bring this all together, we've really taken a deep dive into some fascinating frontiers of AI research today.
I certainly have.
We've explored these AI architectures designed to mirror aspects of human thinking, the incredible advancements in multimodal models that understand and generate all sorts of data,
Text, image, audio, video.
and the increasing integration of these technologies into real-world business applications across so many industries.
And we've definitely hit on some surprising facts.
Yeah.
Like Gemini Ultra beating human experts on that massive knowledge benchmark.
Yeah, that was a big one.
And that huge market growth predicted for multimodal AI. These aren't just small steps. They feel like significant leaps forward in AI capabilities.
And as you've been listening to this, we hope you're starting to think about, well, the implications, how these advancements might change how you interact with technology in your own life.
Yeah, and the potential for future innovations, we can probably only just begin to imagine right now.
Which kind of leads to a final thought, maybe something for you to mull over. As these AI models get more and more sophisticated, as they process and understand the world in ways that really start to resemble human cognition, what new possibilities, but also what new, maybe ethical considerations will emerge in our daily lives across society?
That's the big question, isn't it?
Yeah.
It's a fascinating, incredibly fast-changing landscape.
Definitely something to keep watching.
Absolutely. We encourage you to keep exploring these developments.